Welcome back to another lesson in MCR3U. Today we'll be looking at applications of quadratic functions. So here in the first problem, it says a water balloon is catapulted into the air from atop of the building. The height h of t in meters of the balloon after t seconds is equal to this equation. H of t is equal to negative 5t squared plus 30t plus 10. So here, if we draw ourselves a little diagram on the left, so here we know that, again, in this situation, because it's in standard form, our 10 value will be our y-intercept. This means that at the starting point, it will be at 10. And then it will catapult it up and then drop down to the bottom. The quadratic would look like that again, but it won't be negative at any point here because there can't be negative time. So here we're only looking at the positive side of the quadratic. So here it says, how long will the balloon be in the air? So here we're looking at time to the ground, and here we need to find the x-intercept. So here we can rewrite our equation h of t. We can factor out a common factor of -5. So we have -5 t squared minus 6t minus 2. Here, the t squared minus 6t minus 2 is not factorable, so we're going to have to use our quadratic formula. So here we have t is equal to negative b, so -6 plus or minus square root b squared, which is -6 squared, minus 4a, which is 1, and c, which is -2. And that's all over 2a, which is 1. So here we'll get -6 plus or minus, sorry, we'll get 6, because negative times negative, so it's 6 plus or minus square root. Underneath the square root be 44 over 2. So here we can rewrite this as 6 plus or minus 2 square root 11 over 2. So here we'll get two answers. We'll get t is equal to 3 minus square root 11, and that'll give us approximately negative 0.32. And so that won't work because that's a negative. That would be the one that's behind the the uh, y-axis. So that'd be the negative value. Then we get another answer of t is equal to 3 plus square root 11, which we get as approximately 6.32. And so that's the value that we have here. And so here we can see that therefore the balloon will be in the air for 6.32 seconds. Okay, here it says, when will the balloon reach a height of 30 meters? So that means here the h value is equal to 30. So we can sub h is equal to 30 into our equation. So here we have 30 is equal to negative 5t squared plus 30t plus 10. We're going to move the 30 to the other side, so we're going to subtract by 30. And here we have negative 5t squared plus 30t minus 20 is equal to 0. Here again, we're going to factor out a negative 5, and we'll get t squared minus 6t plus 4 is equal to 0. Again, t squared minus 6t plus 4 is not factorable, so again, we're going to have to use our quadratic formula. So here we have t is equal to, again, negative 6 plus or minus square root e squared. So negative 6 squared minus 4, a which is 1, c which is 4, over 2a, or 2 times 1 here. So here, when we simplify, we'll get 6 plus or minus square root 20 over 2, which we can rewrite as 6 plus or minus 2 square root 5 over 2. So here we'll get two answers. We'll get 3 plus square root 5. So here we'll get t is equal to 3 plus square root 5. This gives us approximately 5.24. And we'll also get t is equal to 3 minus square root 5, which will give us approximately 0.76. Okay, so here we see that there's two answers. So here, therefore, the balloon will be at 30 meters at 0.676 seconds and 5.24 seconds. Okay, let's look at this next problem here. So it says the sum of the squares. So sum of the squares of two consecutive odd integers is 290. Find the integers. So here we're going to have to write our let statements. So we're going to let x represent the first odd integer, and we're going to let y represent the second odd integer. And here we know that if we have x being the first odd integer, then the second odd integer needs to be added by 2. So for example, if we had 1, our next consecutive odd integer would be 3, and then 5, and then so on. So each time we're adding it by 2. So here we know that y would be equal to x plus 2. So here, if we wrote our equation, it would be x squared plus y squared is equal to 290. We know that y squared is equal to x plus 2. So here we can rewrite it as x squared plus x plus 2 squared is equal to 290. Now we're going to expand. We have x squared plus x squared plus 4x plus 4 is equal to 290. Here we're going to collect our like terms of x squared, and we're going to move the 290 to the other side to make the equation equal to 0. So here we have 2x squared plus 4x minus 286 is equal to 0. Here we're going to factor out a common factor of 2. So we'll be left with x squared plus 2x minus 143 is equal to 0. So here are two factors will be x plus 13 and x minus 11 is equal to 0. So here we have two answers. This is equal to negative 13 and x is equal to 11. And so here, if x is equal to negative 13, and here we get y is equal to x plus 2, so y will be equal to negative 13 plus 2, and therefore y is equal to negative 11. Here, if x is equal to 11, then we have y is equal to x plus 2, y is equal to 11 plus 2, and y is equal to 13. So here, therefore, the integers can be negative 13 and negative 11, or 11 and 13. Okay, so let's continue on with this third problem here. And it says the revenue of a company is defined as the amount of money the company earns from selling a product at a given price. You can set up an equation for the revenue using this formula. Then revenue is equal to the number of items times the price of the items. So here it says a sportswear store sells baseball hats. Last year, the store sold 500 hats at $14 each. The store manager is planning to increase the price. The consumer survey shows that for every $2 increase, there'll be a drop of 40 sales per year. So here I highlighted the the number of items in yellow. So here it starts with 600, drop of 40 sales per year. And I highlighted in pink the price. So it starts at $14 and there's a $2 increase. So here we provide some let statements. So we're going to let X represent the number of price changes. And we're going to let R represent the revenue in dollars. Okay, so here we'll write our equation. So again, revenue is equal to the number of items. So again, number of items was highlighted in yellow. So we start with 600 and there's a drop of 40 sales per year. So 600 minus 40x. And that here represents the items. And then we're going to multiply it by the price of the item. So it starts at 14 and there's an increase of $2. So that would represent the price. So here it says, how many times did the store have to change the price to maximize the revenue? So whenever we see maximum or minimize, that means we're looking for the vertex. When we're looking for the vertex, there's a few ways that we can solve for it. So the first way to solve for the vertex is to complete the square. The second way to solve for the vertex is using the formula negative b over 2a. And the third way to solve it is to average the x-intercepts and divide by 2. So here, to start, we're going to look at averaging the x-intercepts and then dividing by 2 to see kind of how this works here. So here we have, so we'll make 600 minus 40x equals to 0. So here we have 40x is equal to 600. And so here x is equal to 15. And we'll make 14 plus 2x equal to 0 as well. And so here we have 14 is equal to negative 2x, and x is equal to negative 7. So here we'll average, or we'll just add the x-intercepts together and then divide by 2. So here our x value of the vertex is equal to adding the x-intercepts and dividing by 2. So here we have 15 plus negative 7 divided by 2. And so here, the x value of the vertex is equal to 4. And what that means is that, therefore, to maximize the revenue, the store should change the price 4 times to maximize revenue. Okay. And here it says, what should the selling price be to maximize revenue? So the price is represented by the equation. So price is represented by the equation 14 plus 2x. And so here we have our value of x is equal to 4. So we'll sub x is equal to 4 into the equation. 14 plus 2 times 4, which is equal to 22. And so here we see that, therefore, the price should be $22 to maximize revenue. And here it says, how many baseball hats did the store sell when the revenue has reached its maximum? So therefore, we're looking at items. And items formula is 600 minus 40x. And here again, we'll sub in x is equal to 4. Here we'll get 600 minus 40 times 4 is equal to 440. So here, therefore, the store sold 440 baseball hats, and the revenue reached its maximum. Okay, and then now it tells us to look at the maximum revenue. And so again, remember the revenue is equal to the number of items times price per item. And so here we solve that in part B and part C in this question. So here, the number of items was 440 when it maximized revenue, and the selling price was at $22. So here we have 440 times 22, which is equal to $9,680. Here again, therefore, max revenue is $9,680. Okay, so let's look at this last question here. So it says a football is kicked off the ground after traveling a horizontal distance of 24 kilometers. It just passes over a tree that is 3 meters tall before hitting the ground, 28 meters from where it was kicked. Okay, so let's look at some information that's given here. So again, traveling a horizontal distance of 24 meters, it passes over a tree that's 3 meters tall before hitting the ground at 28 meters where it was kicked. So here, if we draw ourselves a diagram, so here we have our football. It was kicked. It was kicked, and then it lands at 28 meters from where it was kicked. And at 24 meters, it passes a tree that was 3 meters tall. Okay, so here we're going to look at these questions and we'll put our let statements here. So here we're going to let H represent the height of the ball in meters. We're going to let T represent the horizontal distance. The ball is in the air. Okay, so here we know that it starts at 0. And so here, if we create our equation, we know that our two x-intercepts, one is at 0 and one is at 28. So here we can write, we don't know our a value, but we can rewrite it as t minus 0. Actually, we'll represent it as d, which makes a little bit more sense. So we can represent it as d. So here we'll have a times d minus 0 and d minus 28. Here, if we factor it out, or sorry, if we expand it here, we have h is equal to a times d e minus 28. And here we know that we actually have one point here, which is at 24 and 3. So here what we're going to do is we're going to sub 24 and 3 into this equation to find a. And so here we get 3 is equal to a times 24 times 24 minus 28. So here we get 3 is equal to negative 96a, and a is equal to negative 3 over 96, which is equal to 1 over 32. So here we get our equation. So that's part A. So here our equation is h is equal to negative 1 over 32 d times d minus 28. Next, it says determine the maximum height of the ball. And so here, the max height of the ball is, again, when we look at the two x-intercepts and divide by 2, so this is the x value of the vertex, which is where the max would be. So we can add the x-intercepts and divide by 2. So here, our x-intercepts are 0 and 28. Let's divide by 2. So here, we know that when d is equal to 14, that's when there is the maximum height. So now we can sub that back into our equation. So max height when the distance is equal to 14. So sub that back into our equation. So here we get h is equal to -1/32, 14 times 14 minus 28, which is equal to 6.125 meters, or in a fraction, 49/8 meters. So here we write, therefore, the max height of the football is 6.125 meters. And here it says, how far has the football traveled horizontally when it reaches its maximum height? So here we're going to try to find the d value here. So here we sub in 6.125 is equal to -1/32d, d minus 28. Here we're going to expand, so we have 6.125 is equal to -1/32 d squared plus 7/8 d. Here we'll move the 6.125 to the other side. So here we have 0 is equal to -1/32 d squared plus 7/8 d. And remember, we rewrote 6.125 as a fraction, which was 49/8. So we'll rewrite that as -49/8. And here we're going to multiply everything by 32. Here we get 0 is equal to negative d squared plus 28d plus 196. Oh, sorry, here we're going to multiply by -1. So here we'll get 0 is equal to d squared minus 28d minus 196. And here when we factor it out, we'll get d minus 14, d minus 14. This means here, again, that d is equal to 14. So here, again, the max height is reached when the ball travels 14 meters. And so that was just a check on this last question.